first off drawing up the figure, and then I'll explain what we're going to do. So we have mass B is going to be 7 kilograms, making this B. Mass B. And then we also have mass A, which is 5 kilograms. And we know that it's 10 centimeters from the floor, and they're going to collide. Okay, so they're going to collide. Mass A and mass B are going to collide. So now let me read you the problem. In this figure, right, the one I just drew you, the upper ball is released from rest, collides with a stationary lower ball. So the MA that I wrote here, MA is going to collide into MB. And that's, where am I at? Okay, and sticks to it. So it's going to stick to it afterwards. Okay, that's important as well. The strings are both 1 meter long. So this is 1 meter, 1 meter. The upper ball has a mass of 5 kilograms and is initially 10 centimeters higher than the lower ball, which has a mass of 7 kilograms. Find the frequency and maximum angular displacement of the motion after the collision. So we're going to be looking for 3 different things that are very important in this problem. So we're going to look for we have to convert to the mechanical of MA, right? We also have to convert of the linear momentum to the collision of MA and MB, right? And then at the end, we'll have to have like a consensus of mechanical energy with MA and MB, okay? So there's a lot of different things going on, but it's pretty simple once you get the right equations down. So essentially, the first equation we're going to be working with is trying to isolate VA, right? Because we need to find the VA. We know the VB, but we do not know the VA. So here we go. We have mg AJ equals to 1/2 MAV squared. Now we know V squared is equal to 2GH. And we have VA is equal to 2GH, right? That's what we originally 2GH, the height. So now that we have that, now we can work with MA, right? We can work with the first ball that we had. So now here we go. We will work this problem of MA, VA. We'll turn it into MA plus MBV. Now, the V, we can convert this equation into this. MA squared 2GH over the MA plus MB. Now that we have that, we'll plug in numbers. And if we plug in the right numbers, which I'll draw in green so it's easier to see, it's going to be this. We'll have our 5, we'll have a 2, we'll have a 10, and then we'll also have a 0.1, right? Because we know that was just 10 centimeters, or basically it's off meters. And we'll have 5, we'll have 7. So mass A, mass B in the bottom, so we get 13. We're getting 5 over 12. 5 over 2, sorry, out of 12. So then that's our answer right there. Now, that's our first part. We're not done yet. Now we'll have this. We'll work with this. 1/2 5 squared B squared, right? And it's going to equal to GH. Now, if we were to work out the problem now, we can draw this out. H is equal to 25.2 over 30. This is 0.2 over 13 squared, and that's going to equal to, that's times. This is times 2, by the way. Sorry, I keep saying 2. Okay, so 50 over 169. And after you get that, you're going to get 3 centimeters. This is the eventual thing you're going to get, right? 3 centimeters. After you get your 3 centimeters, right, we get to move on to the final part of the problem, which is going to be, well, not the final part of the problem, but the next part of the problem. So now that we have this, you know, it's 3 centimeters, the second ball, the mass B. And then we know that it's the other one is A. So now we have to work on it here with 1 cosine theta is equal to 0.03, right? After we get the 1 minus, right? We know that this is the centimeters, right? Because we're basing it off of this. And now we have to calculate it, and eventually you're going to get this number, 0.97. And then if you plug that back into the calculator, it's just mu theta 2. Okay? So we solved that part. And before we solve the next part, we have to also do the same thing for the other one. So we have here theta. We're trying to understand the angle, right? We got 1 meter, 1 meter, 1.5, 1.5 times 10 to the negative 2. And then we get that, we get 0.985 after we get 1 minus 1.5 times 10 to the negative 2 equals 0.985. Okay? So after I stage out those numbers, now we have to work with what we have. We're going to work with this now. 985. Now to isolate the theta, right, we have now arc cosine 0.985. And that's going to give us our 0.2 rads. And then we're not done yet because we still have to, calculate the last part, the third part that I talked about. So this is the first two parts of the problem, right? So now we have to continue on. And it's going to be, give me a second, scrolling up on my notes. So now we have to do this part here. Here we go. Getting my notes. Give me 1 second. Okay, so next part of the notes, we're going to have to visualize it again, right? The ball is swinging down here to this one. And we know this is L, right? We're going against this. This is the T, and this is the 3. This is the 5. And this is the mg that's working against it. And we know this is theta in here. And we know that the mg is going downwards, right? Because we know that this is parallel. So we know the mg is going this way. Okay. So now that we have all that in mind, this is the equation we'll get. mg sine theta equals ASM. But we have to remember that we can cross out the m's, right? Because they're against each other, so they won't be really matter. And then that theta is small, and sine theta, it has to be greater than the other one. So now we have negative g theta equals to AS minus g over L, which is times S equals AS. Next up, we have S is equal to L theta, right? Just to remind you where this is from. S is over L, and we know now that W2 squared is equal to G over L, and eventually that's just this GL. Now that we have that, let's go back to here that we left originally with A, right? Equals to minus W squared, X is AS equals negative W squared, S, and W equals 2 pi. So now we have that. That's our next part. We're going to continue writing. And we have now the W2, this equals to this, right? Now we're going to be left alone with this eventually. Equals 1 over 2n with G over L. After we have the G over L, we can plug in the numbers. Once we plug in the numbers, it'll be this. It'll be this. We'll have 1 over 2n over GL. When we plug in the numbers, it's going to give us 0.5, negative 1. And we're going to move on to, now we know that we go back to our diagram that we drew, right? That 0 theta is greater than 1. You know that if there was another one here, right, L, swinging here or swinging there. This would come down this way with sine. And we know that A is equal to negative W2 times X. This is W here. And we know that's harmonic. We know this is AX, depending on what we're going to be looking at. So next time we just have to plug it into that equation, and we'll honestly understand that those are the answers. So we got the 0.5. There we go. So those are the two things we were looking for. Remember, don't lose sight of what we were looking for, guys. What we were originally looking for was that the frequency and the maximum angular displacement, which we just found with the numbers we had after the collision. So we found it after the collision, like what would occur after the collision for both balls that happened. So yeah, thank you so much.